This videotape will show you two methods of sharpening or grinding twist drills in the machine shop. The first method you will see is called hand grinding. This is performed on a pedestal grinder, with the machinist doing all the manipulations by hand. The other method will show you how to perform the same task using a drill point grinder. It is necessary for you to know both methods, as all machine shops are not equipped with precision drill point grinders. After viewing this videotape, you will be able to write down the safety procedures used in the machine shop and when sharpening drills, identify the parts of a drill, describe the method of sharpening drills by hand on the pedestal grinder, and describe the procedure of sharpening drill points using a drill point grinder. In the machine shop, safety must always be the #1 concern. When sharpening drills, wear safety glasses with side shields. If safety glasses with side shields are not available, wear a face shield. Remove all rings, jewelry, and watches. Keep your sleeves above the elbow. And never use rags to hold a drill when you are sharpening a drill by hand on the pedestal grinder. Let's point out the basic parts of a drill. There is the point, the body, flutes, and the shank. Shanks come in two varieties, the straight shank and the tapered shank. You usually use a drill chuck to hold a straight shank drill. The tapered shank drill usually has a neck which separates the body and the shank. At the end of the shank is the tang, which fits into a drill sleeve or spindle of a drill press to provide a non-slip drive. You should know that drills come in many sizes and classifications. In number drills, the sizes range from the smallest diameter, which is a number 80 and is 13.5 thousandths in diameter, to a number 1, which is 228 thousandths in diameter. The letter drills begin with the A drill at 234 thousandths in diameter and increase to a Z drill, which is 413 thousandths. You will find the numbered and lettered drills on most standard drill charts, and they will come with a straight shank. Straight shank fractional size drills are available from 1/64 inch to 1/2 inch. Drills of larger than 1/2 inch in diameter generally have sizes increasing by 1/64 of an inch up to the larger diameters. These larger diameter drills are usually equipped with a Morse taper on the shank. You perform the sharpening or grinding operation on the point of the drill. Let's look at the parts that make up the point of the drill. This is the dead center or web of the drill. As you can see, it is chisel-shaped. The lips are actually the edges which do the cutting in a drilling operation. The margin is the raised edge which starts at the end of the lip and continues down the body along the flute. The heel of the drill is that part which slopes away from the cutting edge. The imaginary center line which runs through the center of the drill from the point to the end of the shank is called the axis. You have to grind drill points to different angles depending on the type of material you are going to drill. For harder materials, you will need a larger included angle on the drill point, or a flattened angle drill point. This angle ranges from 135 degrees to 150 degrees. When you are sharpening a drill for drilling softer materials, such as wood, plastics, or non-ferrous metals, the included angle on the drill point is smaller, or has a long angle point. This angle ranges from 60 degrees to 90 degrees. A tool which may be used to measure the lip angle and length is called a drill point gauge. When a drill point gauge is not available, a protractor and scale may be used. but the protractor and scale are not as effective and convenient to use as the drill point gauge. A standard general all-purpose drill has an included angle on the drill point of 118 degrees, which falls between the angles used for hard and soft materials. For this demonstration, you will grind a drill to an included angle of 118 degrees for general all-purpose drilling. The first step in sharpening a drill by hand on the pedestal grinder is to check the grinding wheels to make sure they are square or straight on the face of the wheel. If the wheel is cupped or not true, use the wheel dresser to true up the wheel. Hold the drill shank with one hand, and with the other hand, hold the drill near the point. When you are grinding smaller drills, you may want to rest the hand holding the drill point on the tool rest of the grinder. Position the drill above the center of the wheel so that it is in a horizontal plane with the cutting edge parallel to the face of the wheel. In this position, the axis of the drill should form an angle of approximately 59 degrees with the face of the wheel. When the drill makes contact with the grinding wheel, slowly move the shank downward and slightly to the left. You must allow the drill to slip forward freely while keeping contact against the wheel. On larger drills, you may rotate the drill slightly, but be careful not to rotate it too much to cut into the opposite cutting edge. When you are grinding a small drill, do not rotate it. The upper clearance for the heel of a drill is usually between 8 and 12 degrees. Some of this angle is obtained from the curvature of the grinding wheel. When you have ground one lip, rotate the drill 180 degrees and grind the other lip using the same procedure. You should take the drill away from the grinding wheel occasionally. Check the point with a drill point gauge for correct angle and for equal lengths of the lips. If the length of the lips are unequal, you should always regrind the shorter lip so that it matches the longer lip. If the angles are not correct, you have to change the angle of axis to the face of the grinding wheel. You need to repeat this adjusting procedure until both lips are the same angle and the same length. If a drill has been sharpened with an unequal angle, the lip with the large angle will do most of the cutting. This will cause the opposite margin to cut into the wall of a hole. If the drill has been sharpened with unequal lip lengths, both lips will cut with equal force, but the drill will wobble and one margin will cut into the whole wall, producing an oversized hole. The drill point grinding machine takes the guesswork out of the sharpening process and produces precision sharpened drill bits in much less time. There are many types of drill point grinding machines available on the market today. Some of them will sharpen drills on the face of the wheel, but some use the side of the wheel. All drill point sharpeners have some method of holding the drill in the proper grinding position. They also usually have some method of adjustment for drills of different lengths. Another feature found on many machines is a self-contained wheel dressing system. The wheel dresser usually has a diamond tip which produces a truer grinding surface on the wheel. This particular drill sharpening machine will sharpen drills on the face of the wheel and will accommodate drills from 1/8 inch to 1/2 inch in diameter. To use this machine, place the drill to be sharpened in the holder against the locator. Secure it in place. Some machines must be adjusted to 59 degrees, which is the angle for all-purpose drilling. This machine is preset. Turn the machine on. Bring the drill point into contact with the wheel. and move the drill point back and forth across the wheel. This will grind the drill point to the desired angle. Rotate the drill bit 180 degrees and grind the second cutting edge. If you have set the angle on the machine properly, the angle of the point will match the drill point gauge. If the setting on the collar was the same for both sides, then both lips should be the same length. It is the common practice in most general machine shops to use the hand sharpening method for drills larger than 1/2 inch in diameter. However, if the machine shop is equipped with a tool room or tool grinding area, all sharpening for the shop may be done there. Let's review what you have seen in this videotape. You saw some of the safety precautions you should follow in the machine shop while sharpening drills. You were shown the various parts of the drill, and you saw the procedures you should follow to properly sharpen a drill by hand and with a drill point grinder. The speed and precision with which you can sharpen drills will contribute to the quality and quantity of work you can produce in the machine shop.